Hello everyone, welcome to the course on data structures and algorithm. In this video we are going to be talking on binary tree. In our previous video we have talked about the basic terminology regarding a tree. So binary tree is also a kind of tree wherein the condition is it can have maximum 2 children. That's a condition. If it satisfies this condition, we can call it a binary tree. So let us look at this tree. In this one, if you can see that how many children 4 is having, it number 5 is having, it is having 2 child. For 2 there are 2 childs. For 7 there is no child. For 1 we are having 2 child. For 3, 6 and 9 we are having 0 child. For 4 I am having 1 child. For 8 I am having 1 child. So if you look at it, either I am having 0 child, 1 child and 2 child, means maximum 2 child. So this is a binary tree. So you can call this as a binary tree. The condition is it's a hierarchical data structure where each node has at most 2 children. The leftmost child we will be talking about, we will be referring as left child, and the right one we will be referring it as the right child. So if I'm having something like this, if I'm having something like this, then this is not a binary tree. Why? Because in this case there is a node wherein the number of children are more than 2. So if this is the situation, this is not a binary tree. So it can have either 0 children, 0 child, 1 or 2. Right, and each node contains 3 components. If you carefully look at any node, for example, if I take a look at this particular node, look at this. I'm having one component as data, means I will be putting 5, 10, 20, 30, whatever, but that's a data part. Second is the pointer to the left subtree, and third is the pointer to the right subtree. So now there are 3 members, 1, 2 and 3. So let us try to look into detail. So you can see now this over here, this is my data, this is my data, and this is the right pointer and this is the left pointer. So left pointer and right pointer. So in and all, one number is data, 2 and 3. 3 members are there with every node. Then same is applicable to other nodes also. Over here also data, left and right. Over here also data, right and left. So likewise you are having 3 members in each node. Now let's move further. So how do I declare in programming? So we will be declaring a structure node with 3 members. The first one is my data member. The sequence could be anything, not necessarily you write data as first and left and right as next. You can have any sequence. Then I'm having a left member, which is a pointer to same type of structure, and third one is also a pointer to same type of structure. So this is a structure definition to define a single node. Now let us see some binary trees. Can I call this as a binary tree? Yes. Why? Because it does not have any child. So a node with no child child can be either 0, 1 or 2. So if it is 0, yes, this is a binary tree. How about this? Can I call this as a binary tree? So in this case the number of child equal to 1, and in this case the number of child equal to 0. So whether it is 0 and 1, yes, we can call this as a binary tree. Then in this one, can I call this a binary tree? For A the number of child equal to 2, but for B and C there is no child. So whether it is 0, 1 or 2, then it's a binary tree. Then if I have something like this, is this a binary tree? So let us count the child. For A, number of child 1, for B the number of child 1, the C number of child 1, for D there is no child. So if it is 0, 1 and 2, yes, it's between 0, 1 and 2, then this is a binary tree. How about this? Let us count again. For A, number of child 1 and 2. For B, number of child 1 and 2 again. For E, F and G no child, and for C only one child. So you can see either 0, 1 or 2 child. So yes, this is a binary tree. What about this now? So let us count. Over here the number of child equal to 0. Sorry, for A it is 3, and for B, C and D it is 0. So now this is exceeding 2. So this is not a binary tree. So now let us see some properties that each node can have maximum 2 children, that we have already seen. Now at any level the maximum number of nodes can be 2 raised to n. So let us draw a tree like this. 1 2 3 4 5 6 7 8. These are all the leaf nodes, and then I am putting parents to them. That means this one is parent to this two, this two, this two and this two. Then let me put some more parents like this, and this is my root node. So this is the tree. Now number of at any level. So let's see what is the level. We have discussed in our previous video what is a level. So you can consider this as, you know, level 0. This one is level 0. This one is level 1. This one is level 2. This one is level 3. So these are all the levels. Now for any level, let us consider any level. For let's say this one. So 2 raised to 0. This is nothing but my level number. So 2 raised to 0 is equal to 1. So this means I am having 1 node. Now if I consider number 1, level number 1. So 2 raised to 1, that means 2. Means I can have maximum 2 nodes. If I consider n equal to 3, so 2 raised to 2. So 2 raised to 2 is 4. So I am having 1, 2, 3, 4. That's a maximum one. And if I consider the last level 2 raised to 3 in this example, then I can have maximum 8. Maximum means you can have less than that. For example, you can rather than 8 you can have 7, you can have 6, you can have, like for example, this is also fine, because maximum 8 means 7 is good. This is also fine, this is also fine, this is also fine. So these are the maximum number of children. And maximum number of nodes at any tree in a specific height. So if the height, you can see, let's consider height equal to 1. So for that 2 raised to, this is not n, it's 2 raised to height plus 1 minus 1. So 2 raised to 2 minus 1. So 2 raised to 2 is 4. 4 minus 1 is 3. So if I consider, let me draw everything again. So if I am having a tree like this, okay, wherein the height is 1, wherein the height is 1, 0 and 1, means maximum number of edges are 1. So now rather than this, let us put 2 raised to h plus 1 minus 1. So h is 1. So 2 raised to 2 minus 1. So 2 raised to 2 is 4 minus 1. So maximum number of children in the node is 1, 2, 3. You can have maximum 3, means you can have less than that also, no problem. You can remove this also, but maximum. Same way you can continue like this. You can have something like a tree like this, wherein the height is 2. Now you can see the height is 2, because the number of maximum edges from root is 2. So height is 2. So 2 raised to 2 plus 1 minus 1. So 2 raised to 3 minus 1. So 2 raised to 3 is 8 minus 1. That means answer is 7. So 1, 2, 3, 4, 5, 6, 7. So this is nothing but the maximum number of node in a specific tree if the height is given. Now let us try to make a binary tree. So let us take a look at the binary tree from the programming point of view. Now this is our general view. This is our general view. How do we look at a specific binary tree? But this is a programming view, means we look at the node as a structure. So A is a data, and the node is having address, let's say 1000. Okay, and it is having 2 pointer, left pointer and right pointer. So this is your left pointer, let me erase this one. So this one is left pointer, this one is right pointer, and this one is your data. The left pointer points to, let us assume some addresses over here, 1000, 2000, 3000. You can have any addresses over here, then 4000, then 5000, then 6000. all right. So left of 1000 is pointing to 2000, so I'm going to put 2000 over here. That means now it is pointing to this. The right of 1000 is pointing to 3000, so I'm going to put 3000 over here. That means the right one is pointing 3000. Now the left of 2000 goes to 4000, so I'm going to put 4000 here, and the right of this 2000 goes to 5000, so I'm going to put 5000 over here. So that means it points to this, and the right of 3000 goes to 6000. The right side of 3000 goes to 6000, but there is nothing on the left side of C, so I'm going to put null. There is nothing on left and right of this EFG. So for EFG, left and right, I am not going to put any address, but I am going to put null only. Alright, so this is how you can create, or this is how you can visualize a binary tree. Now let us try to implement binary tree in a C programming. So first thing is, we need to see it from the structure point of view. So we declare a structure with 3 members. The first member is data, the second member is left pointer, and third member is the right pointer, and both the pointers are pointing to the similar kind of structure. So struct node. Now in main we don't do anything. In main we just call a create binary tree, and this function will do everything. We are not going to print it in this particular video, we are just going to create it. In next video we will show you how to display the elements. So this particular function will create the tree, and it will return an address. It will return an address of very first, the topmost root node. So now let us look at the syntax and structure of this particular function, create binary tree. So create binary tree is a recursive function. It returns a pointer, as we have discussed that we are going to return at the end root node, right? So it will be returning, we are not passing anything, so the argument is equal to 0. Now let us try to look at the syntax one by one. So first we create a struct node star new node. So we create a new node. So it goes something like this. If we wish to create something like this, and let's assume some addresses also. So this will make the things easier to understand from program point of view. If I put some addresses, and this is something which I wish to create. So I have this kind of structure. So first I'll be creating a new node. Let's say I have created a new node over here. Okay, so this is my new node, and address also you can assume that is 1000 for the second, and then just enter some data. For example, in this case I want 6, so I'll be entering 6. Okay, and if you are done, you will be entering -1. So if you enter -1 means you don't want to proceed any further. So I'm not entering -1 right now. So in this case I will continue further. All right, so in this one new node has been created. I just made a mistake over here. I did not create the new node, but I just created a pointer. So a new node will be created at this point of time. So over here the new node is created. The data that we have entered, like 6, that is assigned into new node. So this is done, and then then it will ask for left node of %d. So left node of 6. Okay, you enter left node of 6, and then now we are recursively calling create binary tree. So this function will be called, and the address of the function that is going to return will be stored in new node arrow left. So I am going to store the address over here. Right now I don't know the address, but it will be written by this function. All right, so now let us go further. let us go further. Now I am jumping from this position. So you need to remember one thing, this is a recursion one. So you need to remember that once this part is over, I need to come back. I need to come back to these particular statements. These statements have not been executed. Alright. So now let us see from here, let's go back over here and then check that enter data. So I'm talking of this left side of this. So I'll be entering, let's say 4. Okay, now 4 is -1. No, in that case create a new node. So again let us create a new node. All right, so new node is created over here. Okay, and I'm going to put that data there, 4 into new node arrow data. So I'm going to put 4 over here, and then let's say I don't want to create this one, just for the sake of simplicity. I don't want to create this one, and I just want to create a simple tree like this only, the 3 nodes only. Okay, so enter left side of 4. So I don't want to continue anymore. So what I'll be entering, enter left side of 4 is -1. All right, so I'll be entering -1 over here. So again I'll go here and I'll enter -1. So the moment it returns -1, it will return null. So the left side of this one is null, but then it will continue this one. Enter the right side of 4. So right side of 4, again I'll call it, again I'll enter -1, and again it will return minus. So it will enter it will set this right side of this 4 null. Now once this is done, now this will return address of this one. For example, the address of this is 2000. So that address will be returned in this particular node, because we called it like this. If you remember, we called it like this, that whatever address will be returned create by name, that will be set into new node arrow left. So new node arrow left is this, so it is 2000. So now it is pointing to this, and then now I need to move further. Now I'll be printing enter right node of %d. So now we are at this location. So enter right node of 6. So again now I am calling this function. Okay, so if I quickly, you can see now I'm calling one more time the recursive one. So let me erase everything, so it will make little things clear, because this is recursion, so you need to be very much careful. So now we are going from this create binary tree, so we are going to this one, and whatever is written I'll be storing in new node arrow right. So I'll be storing new node arrow right somewhere over here. Okay, so again it will ask enter the data, and then in this side, suppose you are entering, let's say 7, this particular one. So I'm entering 7. So 7 is not equal to -1, so it will create new node. So again it will create new node, and then I'm going to put this 7 into new node arrow data. So I'm going to put 7 over here, and then check this out, that left side and right side. So again I'll be calling the left, but in left I'll be entering -1, so this will be null. For right also I'll be entering -1, so this will be null, and now it will come back that create binary tree. So it will return, let's say 3000 address. So that 3000 I am going to put it in new node arrow right. So new node arrow right is over here. So I'm going to put 3000. I'm going to put 3000 over here. So now this is done. And now you can see that return new node. So we are talking of this new node. That means this 1000. So 1000 will be returned. So that will be nothing but my root value. So root value will be 1000. And likewise, if you want to have more nodes, it will recursively call this this function, and you can set 2, 3, and 9. But at this point of time, just for making the thing simpler, I have just executed the program for 3 nodes only. All right. So now if I erase everything, so this is how the whole program will work. All right. So let me show you with how the program is going to be running. So first it will ask for enter data. So enter data is 6. So it is 6. So let's say this one is 1006. Now it will say that enter left node of 6. Now you are entering 4. So let's say the second node is created. So 4. Now it will ask enter left side of 4. Enter left side of 4, and you are entering 2. So let's say 3 4, this one is, let's say 4000. Okay, again it will ask enter left side of 2, but left side of 2 you will enter -1. -1 means null, you don't want to continue. Then it will ask no, fine, no problem, give me right side of 2. So right side of 2 you are again entering -1, that means you don't have anything on the right side of 2. So it will go back one step, and now it will say enter right side of 4. So it will say enter right side of 4, and now you are entering 3. Now you are entering 3. So let's say this address is 5000. Okay, so then now it is asking left side of 3 and right side of 3, and both the places I am entering minus. So I don't have anything on the left side, I don't want anything on the right side, so both are minus. So now it will again go one step back. So over here 6, now the left side of 6 is done. So now it will say enter the right node of 6. Right node of 6. So right node of 6 is, supposing I enter 7. So now this one is 7. So now it will say enter the left side of 7. Enter the left side of 7. But I don't want to enter anything, so I am entering -1. So okay, fine, no problem. Enter the right side of 7. So enter the right side of 7. So I am entering 9. So 9 has been entered as the right side of 7. So then it will ask for left side of 9 and right side of 9. So left side of 9 is -1 and right side of 9 is -1. So both I have set to null. So then it is done. Now whole thing is done. The left side of this whole and the right side is, both the thing is done. So this will create a binary tree. And as I said earlier, we are not going to print this output, so you are not going to get output of this program. In our next video we will see you have 3 different ways to print the output. We will be talking about different traversal mechanism, pre-order, in-order and post-order traversal mechanism, wherein we will be displaying the output. So till then, thank you very much all of you guys for watching this video, and hope we'll see in the next video. Thank you.